Greetings, Earthlings. I use that term because we all share one planet, and I have a tough but hopeful story about stewarding it. I'm an electronics engineer. Since 1995, I've been tracking a technical secret. 30 years of proof points to one conclusion. A key root of our e-waste nightmare is a worldwide electrical safety standard. The exciting news? We can end this. Right now, the solution is truly zero cost. It comes down to changing the value of a single resistor. We can stop the endless growth of e-waste globally with a design change that adds not a single cent to the bill of materials. The problem? A well-intentioned flaw. Actually, the issue originates from standards like IEC 60950, Clause 2.1.17, the Store Discharge on Capacitors test. Its goal is safety, to ensure hazardous voltages in capacitors are reduced to safe levels after power is removed. It specifies a typical discharge time. Within 1 second after unplugging, the residual voltage must decay below 37% of its rated value. For AC power with a half cycle of just 10 milliseconds, this 1 second interval is exceptionally long. The direct consequence is this: the lingering polarized charge during the negative half cycle of the AC acts like a supercapacitor. It violently draws a massive current from the power source, generating an extremely high voltage spike. These spikes can reach peaks exceeding 800 volts. The aggravating factor, the pursuit of low power. The thing is, a more critical situation is driven by mandatory requirements for lower no-load power consumption. This pushes the bleed resistor value to 2 ohm omega or more. With this excessively high resistance, the voltage spikes generated during power line disturbances become far more severe. In essence, this false low-energy compliance, achieved by violating core principles, becomes a major driving force behind the flood of electronic waste. The solution, a simple inequality. The correction, therefore, is remarkably simple and direct. It can be described by a single inequality, R (C) less than or equal to 1/2f. This means the product of the resistance and capacitance, the time constant, must be less than or equal to the duration of one AC half cycle. This ensures the X capacitor fully releases its charge in each AC half cycle. The capacitor then provides pure filtering and does not contribute to any disturbances. The proof, validated in practice, the effectiveness of this inequality rule has been perfectly validated in mass-produced power supplies. Furthermore, modifications to the power circuits of various household devices have also demonstrated exceptional performance, resulting in long-term, fault-free operation. The choice is now clear. We can continue to let an outdated standard fuel a crisis, or we can adopt a simple fix that defines longevity. This is not a cost, but a correction. Let's choose a cleaner future. By eliminating the shadow of the resistor, we can begin to dispel the shadow of a global crisis.